Hello everyone. In this video we will see about the continuity problem for a special varieties of questions where the function is defined separately for the rational numbers and irrational numbers. And here also one important variety of function called as a Dirichlet function. We will also see the continuity of this Dirichlet function. So how to solve such type of questions is very simple. See, first function is fx equal to x when x belongs to the rational number. Q for rational numbers. And it is 1 minus x when x is do not belongs to the rational number. That is, here x is belonging to the rational number and here x is belonging to the irrational number. That is, the function is defined separately for x belonging to the rational number and for x belonging to the irrational numbers. Okay, so we have to discuss about the continuity. So this function is continuous only when x is equal to 1 minus x. Solve this equation. Solve this equation. This will give x equal to 1 by 2. So at x equal to 1 by 2, function is continuous. Function is continuous. Otherwise, in all real number, it is discontinuous. It is only continuous at x equal to 1 by 2. So this is single point continuity also we can say. Single point continuity. So this is discontinuous in all the real numbers except 1 by 2. So at all real number except 1 by 2, the function is discontinuous. It is only continuous at x equal to 1 by 2. And how we can find out this point of continuity? We can solve this equation x equal to 1 minus x. Now you can also verify whether it is true or not. How we can say that this x equal to 1 by 2 is the point where the function is continuous. See, when I find out f of 1 by 2, 1 by 2 is what? Rational. So therefore this definition we will use, that is equal to 1 by 2. When I find out left hand limit, that is LHL. LHL 1 by 2 left hand side. Either you will have rational number or irrational number. Correct? Both you can have rational as well as irrational. If you are having rational number to the left of 1 by 2, we will use this definition. This is coming to be 1 by 2. And if you are having irrational number to the left of 1 by 2, you will use this definition, and this is also coming to be the 1 by 2. So doesn't matter we are finding the left hand limit by using this definition or this definition at 1 by 2. Correct? Similarly, for 1 by 2 positive, that is right hand limit. Now 1 by 2 right hand side of 1 by 2, you are also having the same, that is either rational number or irrational number. So you can use any one of the definition, and therefore it is also coming to the 1 by 2. So LHL equal to RHL, that is equal to value of the function. Value of the function. Value of function. Okay. So therefore this function is only continuous at x equal to 1 by 2. If you want to check out for the other real numbers except this 1 by 2, say suppose I want to check at 1. F of 1 is 1. Okay, the value of the function is 1. And the right hand limit we will have 1. And in the left hand limit, what we will have? 1 minus 1, that is 0. 1 minus 1, that is 0. Okay, so in both the cases, see, if you use this rational for the right hand limit, you will get the answer 1. Or if you use this definition for left hand limit, you will get the answer 0. Therefore, it is not continuous at x equal to 1. It is only continuous at x equal to 1 by 2. And that x equal to 1 by 2 we can find out by solving this equation, x equal to 1 by x. Here 1 equal to x square, we will solve 1 equal to x square, that gives x equal to plus minus 1. Here this is the point of continuity. Okay, point, these points, function is continuous. Function is continuous. So this is 2-point continuity function. This function is continuous at these 2 points only, and in all other points it is discontinuous. Correct? Fine. Coming to the third one, this is sin x equal to cos x. Okay, so that gives tan x equal to 1, that is equal to tan pi by 4. Correct? So therefore I can have x equal to n pi plus pi by 4. So at these points function is continuous. At these points function is continuous. Function is continuous. Correct? Now coming to that important function, that is Dirichlet function. What can you say about the continuity regarding that Dirichlet function? Now the Dirichlet function is defined as fx equal to 1 when x is rational and fx equal to 0 when x is irrational. Correct? So therefore 1 is not equal to 0. By this previous argument you can say that 1 is not equal to 0. Therefore it is discontinuous function. Discontinuous function. It is discontinuous everywhere. Okay, you can take any point, okay, and then find out the left hand limit and right hand limit. You will see that the left hand limit, right hand limit, or the value of the function, they all three are not finite, are not equal. Correct? So therefore the function is always discontinuous function. You should remember always that the Dirichlet function is discontinuous function. Now we will solve one important problem. That problem is super important. Now look at this question. This is super important question, that the function fx equal to x square minus ax plus 3 if x is rational, and it is 2 minus x if x is irrational. And this function is continuous at exactly 2 points. Okay, this function is continuous at exactly 2 points. Then the possible values of a are. Possible values of a are. Okay, we have to find out the values of a. So the function uses, it is defined separately when x is coming from the set of rational number and when x is coming from the set of irrational number. So in this type of functions, for the finding the point of continuity, we will solve this equation, that is x square minus ax plus 3, that is equal to 2 minus x. So by solving this we will get the values of x, and those values of x will be the points where the function is continuous. Correct? We know that. So therefore it is x square minus x, a minus a plus 1. A minus 1. Correct? This is a minus 1, because this will give what, x square minus ax plus 1, that is equal to 0. So I can take minus x common, so the a minus 1. Yes, correct. Plus 1, that is equal to 0. So this is quadratic equation. This is quadratic equation, and this function is continuous at exactly 2 points. So there are two values of x, two distinct values of x. That means this equation has distinct real roots. That is, the condition is d is must be greater than 0. That is, a minus 1 ka square minus ka 4 is greater than 0. Correct? So when we will solve this, a square minus ka 2a plus ka 1 minus ka 4 greater than 0, a square minus ka 2a minus ka 3 is greater than 0, factorize a minus 3 into a plus 1 is greater than 0. So Weber method we can apply here. This is minus 1, this is 3. This inequality is positive when x is a is greater than 3. This is negative, this is positive. So this is positive when a is coming from this set and this set. Correct? And therefore we can say that the answer of this question is option C, that is minus infinity to minus 1 union 3 to infinity. Okay, so we have seen the continuity of such functions which are differently defined for the x which are coming from the set of rational number and x which are coming from the set of irrational number, and how to check the continuity of such functions we have seen over here.